Okay, getting some other people through. Awesome.
Yeah, and we are currently live on YouTube.
Okay, wonderful. Let me share
I've
my
just sent
screen.
I've just sent the link to Sophie to send out to people.
Wonderful. Okay, let me figure out how to share it. Here we go. Share the deck. Uh, okay. I think maybe give. Where are you? Oh, here we go. Okay, there we go. Ah, okay, brilliant. I think in the interest of time, and now that we're live streaming, let me just start. Let me just go right ahead. People are still joining, and we've kind of got a lot to go through in this session. But as with all of these sessions, I like just to spend the start. Oh, am I still sharing my screen? Uh-oh, what have I just done?
That's
Uh-oh,
okay. You're still sharing your
am I
screen.
still sharing my screen? Okay.
Yeah.
Oh, it's suddenly taken up the largest screen size you've ever believed. So awesome. So welcome to this session. This is about the Carbon Hack 24 from the Green Software Foundation, which is starting very shortly. So I think we're in the 3-week window now to the start of the hackathon. This year, our hackathon is all about measuring software and specifically measuring using a framework that we'll be building called Impact Framework. You can hack solo or in small teams. I think our prize fund is now 30,000, but we still have several sponsors in the pipeline, so it's probably going to be 40,000 plus prize fund, which we're very excited about. Those prizes are distributed across a number of different prize categories. I'll start off with the bottom of the bottom, which is called Best Plugin. Impact Framework is nothing without plugins. It's actually a very simple framework. The majority of the power of Impact Framework is through plugins interacting and working together. So it's the best plugin that supports and enhances the Impact Framework plugin ecosystem. If your plugin is outputting an impact that isn't carbon, so your plugins can output whatever they want, but and they can be not even a carbon or impact metric, can be something earlier on in the stack. But if your plugin is outputting a beyond carbon metric, such as a waste quantity or water, like other things are being proposed, if it literally outputs that in its return and its outputs, then it comes into the beyond carbon prize, which is a plugin which emits an impact metric beyond carbon. Joseph has a really great one proposed for. He posted something about a glacial melt academic paper, and I think a lot of the beyond carbon prizes are just look at the academic literature right now. What coefficients are people using in the academic literature to represent, beyond carbon metrics? Can you translate that into a plugin, and then other people can just use that the academic guide in the impact framework. We have best content. So the best piece of content published about the impact framework. Now that could be like a piece of training material, but also a case study. So if you've got if you just want to apply impact framework and apply it to measure, somebody's using it to measure, I believe it's an AI use case. And through that process of discussion, we discussed actually what probably would be better to submit to is actually just a case study. We've applied impact framework to measure an LLM. What did we learn? How did we apply it? If you can create a content piece like that, there's a best content prize for you. We've got best contribution to the framework, and we're going to add a separate language to this shortly, but this is effectively um, any other application of impact frameworks. If you're building like developer tooling, which is not part of the impact framework, this is now under best contribution. If you are building something else that sits on top of it, we were kind of limiting this prize category previously, and now conversations have come along, and we're just seeing what people are submitting. There's such a demand to submit kind of developer tooling, which is not like it doesn't make sense to force it to be part of the impact framework. It can live alongside it. This is our best contribution to the framework is now going to be, and we'll be coming up with slightly different judging criteria for that. my Zoom account is being signed in on another device.
Yeah,
Denied.
I got that too. I think you can just ignore it. I think it's just a third person signing in under GSF
Oh, okay,
on
okay.
purpose.
I think it might be my wife. Um, this is my personal account. So yeah, best content, best contribution. And then excitingly, we also have two other prize categories. One's for under 18. So if your entire team is made up of under 18s, then there will be a separate prize for you, a separate prize for you. So you can win this in addition to winning one of the other prizes or just this prize. And if your entire team is made up of undergraduate students at university, again, there's a separate prize for you for just that category. Theoretically, you could be an entire team made up of under 18s who are undergraduates at university. Congratulations, well done with all of your choices you made in your life. Better choices than I made when I was a kid. But theoretically, that's also a possibility as well. Or you could possibly just be one person. You could be one under 18 who's an undergraduate at university. So I suppose that is very, very possible. If you're interested in sponsors, we've got 6 sponsors right now and a couple more in the pipeline. It's $5,000 for a sponsorship seat. You get a seat on the jury, logo on the hackathon site. We get featured, we get mentioned, and mostly I'm interested. We actually reach out to all our sponsors and we're kind of having conversations with them around what is it that you want out of the hackathon. So we started to bring them on here and just have them talk about, well, this is why we think measuring software is important. This is why it's a pain for us. This is why we're sponsoring this hackathon. If you're sponsoring this hackathon, it means you're measuring software is a pain that you have, and you're looking for other people to get creative in some of the solutions. And just quickly, important dates. 18th of March is when it begins. 8th of April is when it ends, and the award ceremony will be 18th of April, which is when we announce the awards. So that's firming up very, very nicely now. I think that's it from this side. What we're going to do for this session is we're going to Joseph's going to go through a new workshop that we've been creating. The impact framework has gone through a few changes in the last couple of weeks. Very, very good changes. Opens up a lot of doors for a lot of people. And we're now going to be giving this workshop. So this will hopefully educate you so you can understand impact framework and also help you understand what are the things you can build around it and how to use it. So with that, I'm going to stop sharing and I'm going to hand the reins over to Joseph to take it away. Oh, FYI, my name's Asim Hussain. I'm the executive director of the Green Software Foundation. And Joseph, introduce yourself.
Okay. Hello, everyone. I'm Joseph. I'm a project manager on the Impact Framework and a developer on the Impact Framework. I'm going to walk through a workshop today of the basics of the Impact Framework. Asim, you can follow along and interject with any questions, or if you want to expand on anything, then please jump in whenever you want to. I'm just going to share my screen.
While you're
Something like
sharing your
that.
screen, I think we'll
Yeah.
just say to people this is the Q&A session. So please fire away with any questions that you've got, fire away during it. If I can answer it, I'll answer it straight away in the Q&A section without interrupting Joseph. But otherwise, we might even interrupt you, Joseph, every now and again, just to
Yeah, please do.
fire away very quick questions. Yeah, okay.
Yeah.
Yep.
So just to check, you're seeing my VS Code right now, right?
I am seeing your VS Code,
Yeah.
yeah.
Okay,
I would
fantastic.
recommend increasing just Control Plusing it a few times.
Okay.
I've got a very big window in front of me right now, screen in front of me, yeah. But other people might not.
How's that? Better?
Personally, I would go up one or two.
Even more?
I
Okay.
would go up one or two more. Honestly, you should see my
Okay.
training
Okay.
videos.
Sure.
Yeah, this
Okay.
is probably the smallest I would go. Yeah.
All right. Okay. That's kind of like filling each letter is kind of filling a big chunk of my screen right now. So
Oh, is it? Oh, right.
if it's
Okay.
okay, I'll leave it there.
Yeah, yeah. Go on, leave it like
Okay.
that. Yeah.
Let's jump right into it then.
Mm.
The very, very, very basics, square zero, the prerequisites for Impact Framework. You need to have Node installed on your machine. And we need Node version 18 or higher to run the Impact Framework. Here's the very, very, very first thing: you need Node installed on your machine. If you want to be cloning our repositories and running like the latest development branches or that kind of stuff, you also need Git. Otherwise, you can just use our npm packages. Okay, so that's the absolute bare minimum requirements to run IF is just node and npm. If you want to run the latest development branch, you also need Git. So with that out of the way, we can talk about installing Impact Framework. To get our latest stable releases, you can just use npm. You just type npm I for a global install -g, and then @grunsoft, which is our abbreviation of green software, and if. Okay, I'm not actually going to run that myself because it's already installed, but that's how you get our latest stable version. That's all you need if you just want to run the IF core features. But chances are you're going to want to run some of our standard library of plugins too, in which case you also need to install some of our plugin packages. We've got two plugin packages. We've got IF models and IF unofficial models. IF models is the absolute core, like the standard library of things that we maintain that we think are just kind of fundamental plugins. There's also the unofficial models, which is kind of a set that relies on some third-party API or some third-party database that we don't necessarily have control over. Like Bovista, for example, it wraps an API call to their service and then returns the data. And that's in things like that are in unofficial models. So you can install those too, exactly the same way. npm I -g @grunsoft IF models or IF unofficial models like that. They do those three things, and you've got our three core repositories installed on your machine, ready to use. Just a note, though, that's how to install the latest stable release of IF, not the latest development versions. And in this workshop, because for the last 2 weeks we've been working really hard on refactoring everything from the ground up, basically from a blank page, rewriting the whole of IF. So in this workshop, I'm actually going to use the latest development version and not the stable release. And the reason for that is because of the refactor, and we are about to cut new releases for all three of the core IF repositories, literally in the next hours to days. And I'd much rather show people how to use the refactored version so that if people are watching this workshop back later, it's still relevant. Otherwise, if we do the workshop on the release version today, it's just going to be made obsolete by in a couple of days' time.
Joseph, just really quickly, there's a question in the chat. Can those commands just be copied into chat? I don't have the commands you're going to type, but just FYI, if you type anything of any meaningful, just drop it into chat. But there will also be not in the next couple of days, but there will also be all this will also be written up as a document on the IF Docs website shortly as well. Guinea pigs right now.
I've been maintaining firstly a branch of the documentation, secondly how to migrate to the refactored version document, and all of it we share. As soon as these changes become releases, all of that documentation will be shared along with it. So there'll be guides for how to migrate to the new version. It's pretty small, to be honest, but the changes for the user are pretty trivial overall. There might be some small changes for plugin developers, but again, they're very manageable. Yes, okay, so where were we? Yes, if anyone does actually want to follow along live, then you have to clone our repositories and check out the refactor branches. And to do this, you can just have a clone of the repository or a fork with the refactor branch checked out, and then you can just simply enter the IF root and just npm I, and then use npm link to install the plugins, which is just npm link, and then the same commands again. You can use something like that. Oops. And that'll have everything locally installed, ready to use. Okay, so that's all I've done in advance of the workshop. And if you follow those steps, then you'll be kind of ready to follow the rest of the workshop too. Okay, let's get right into running a quick start, a pre-existing manifest file. Okay, so the scenario that we're covering right now is you've just installed the IF, you've never used it before. So first experience with the IF, You just want to see how the command line interface works, and you want to get familiar with the manifest file and some output options. So probably the first thing to do is just zoom out a little and just define some of those terms that I just used. There's the CLI, the command line interface, the manifest, etc., etc. Those are so fundamental to the IF, you can't really understand it until you've got some of those terms. Firstly, the manifest file. The manifest is a YAML file that defines the architecture of the applications that you want to measure. But it's also more than that. It contains all of the usage metrics that you're going to use to drive the IF calculations. So on the screen right now, you've got a very basic manifest file. We can just quickly just go through the basic elements of the manifest. Up here, we have some metadata, some just very simple thing, the name, a description, which can be really just anything you want, just a basic demo. This is really just for you to keep track of your own manifest files so you know what you're trying to describe. Tags, which again can be kind of anything you want. Maybe you want to tag this as web or backend or something like that. It's kind of this sort of free metadata to help you keep track of your own manifests. Then we have the initialize block. Now this is where the really important stuff starts. The initialize block is where you tell the IF what plugins you are going to use to calculate metrics in your manifest file. So everything, all the different plugins that you want to use have to be instantiated here. In this very basic example, this is kind of the most basic manifest. You've got one plugin and one component, that's all. So it's as basic as it can get. In this one, we're just initializing one plugin, and it's the Teeds curve plugin from the unofficial models repository. So we provide the name of the model as the key, the path, which is where it was imported from, the method, which is the name of the function, the exported function in the plugin repository in the actual code. And then there's this block for global config, which is something I'm going to speak about in detail just in a little while. But basically, this just configures the plugin and tells the IF what global options to use when it executes. In this case, we're choosing an interpolation method. Next, we have the tree itself. Now, the tree is where we define all of the architecture for the application that we're trying to measure. In this case, there's only one component. So there's one thing that we're measuring. Maybe it's a server, for example. But you could also have very, very complicated trees where you have, a back end, a database, a front end, a bunch of servers, or maybe some nesting. And we'll show how that works just a little bit later. Right now, we've just got one component in the tree. So it's not really a tree at the moment. It's just the thing that we're measuring. In the tree's divided into children. So again, this is something that's only really relevant when there's multiple components. For now, there's only one. So we can kind of just skip this. The name of the only child, in this case, child 0. And then we have the configuration and the input data for that component of your application. The first field is called defaults. But maybe actually I'll just highlight this field first, the inputs field first, because the rest will make more sense when you know what inputs are. The inputs are the actual data that we're pushing through a plugin. Right, so every single time step, all of this together, this whole array is a time series. Each observation in the array has a timestamp, so we know when this refers to, and a duration, so we know how long the observation covers, how much time the observation covers, and then some kind of metric. In this case, CPU utilization. And in this most fundamental, most basic example, we're just providing that manually in the inputs. We're just providing the CPU utilization as input data ourselves, just putting it in. And we have 3 time steps. Each one is 1 second long. That's our input data. That's what is being passed to each plugin to be executed. Okay. Above that, we have the pipeline. This is the set of models that input data is being passed into. So in this case, we're passing these 3 observations to the Teeds curve model. That's all we're doing. The next block above that is defaults. And defaults is basically there to protect you against this sort of case, where one of the critical pieces of information is either missing, or it can be there as like shorthand for if you don't want to, if you have something like thermal design power, the TDP of the processor, where it's going to be the same in every single time step, you can provide it into defaults and it'll be copied into all of those different, it can be copied into every element in the array. So kind of a convenience tool for manifest writers or a fallback. It's kind of got dual purpose. So that's it. We could actually execute that manifest file now using the CLI. These are the basic. This is the basic structure of a manifest file. It's an extremely simple one. Some will be very, very complex, but basically they're going to conform to this fundamental structure. These are the basic building blocks of the manifest file. So we can actually run that right now. I'll just run IF. So this is the command line tool. This is the CLI. The command that we're using is IF for Impact Framework. And we only need one argument, and that's the manifest. This is the path to this file. For me, it's in examples. And we can just run that. And our output data is dumped to the console. You will see, if you look at this, let me just drag this up. You will see if you look at this, that this persists the same structure as the manifest file. This basically is the manifest file, but it's got an extra block of data in it. So this is all the same. This is all the same as in the manifest, but now we have an outputs block appended to it. In the outputs block, we still have our timestamp, duration, CPU utilization. Our CPU TDP has been copied down from defaults, but now we have a new field added, which is the CPU energy. And this is the result of passing those inputs to the Teeds curve. The CPU energy has been calculated and it's been appended to each observation in the array. So we have one for each timestamp. Okay, now, just to note, if you're using the latest release version of the IF, you have a slightly simpler command to run. You don't have to do the IF, the npm run. You can just IF, and you don't need these two dashes either. You would run it like that. But for me, with the local install, it has npm run prepended to it. Okay, so that's it, right? That's how you run a manifest file. It's as easy as that. The manifest itself contains everything that the IF needs to do all the calculations and to generate output data. And as you can see, the output is dumped to the console in this case, and that's kind of fine for this demo. But in many cases, you'll actually want it to get dumped into a file. And to do that, you just add the output flag or output command to the the CLI, and just get back to where I was. You can just add the output flag and then a save path. So I'm going to put this one in examples. YAML. If I run this now, it won't get dumped to the console anymore. Instead, this is going to be redirected to basic.yaml. We'll just let that run. Yeah. And it's here. The same data is exactly the same as what was in the console. Now it's dumped to a YAML file instead. Okay. So, right, yes. What we can also do here is we can go back to the manifest file, which I've got open on the screen. We can tweak some of those values. so we can see that the outputs are changing when we change the inputs. So one thing we could do, we could change the CPU utilization. At the moment, it's 80. And let's just have a quick check. The CPU energy is here, 0.0000255.6. If we drop that down, let's drop it down substantially so the change will be obvious. And run this again. Okay, and now you can see we've got a different value for CPU energy. So we're passing different inputs in, the calculation is exactly the same, we get different outputs as you would expect. So, okay, so at this point, we've kind of shown the most basic functionality of the IF. We've introduced the idea of a manifest file, but it's also kind of interesting to think about the manifest file a little bit more deeply, because the powerful thing about a manifest file is it's not just config. It's not just a config file. It's not just a table of data. It's something more like an environmental audit expressed in YAML, but one that you can hand to someone and they can read it and say, okay, I can see your architecture. I can see your input data. I can see all your assumptions. I can see your calculation pipeline. And now I'm going to run it again, which is as simple as just passing it to the IF. And I'm going to verify your results. Or maybe it's, I think you've used an inferior plugin for X step in your pipeline. I'm going to swap it out for a more appropriate one, and I'm going to hand you back your updated results. And so the idea is you don't send people your final set of numbers if you want to show your environmental impact of your application. You send them the manifest file because it bundles all of your calculation logic, all of your assumptions, all of your architecture, all of your input data in a way that can be verified or challenged openly, freely. Or maybe it's not even an audit type situation at all. Maybe this is something you're doing for decision making internally, and you want to know what are the levers that I can pull to most dramatically reduce my environmental impact. So you can create a base manifest and then create tens or hundreds of hypothetical test scenarios that change that base manifest in some way and run them all through the IF to find the set of conditions that gives you the most environmental performance improvement on some specific dimension that you're interested in. So the manifest is not just a config file. I like to call it an executable audit, or it's a platform for forecasting environmental impacts, for supporting business decisions related to ESG, or even cost efficiency or stuff like that, really. Okay, moving on. Updating, let's talk about updating a manifest. So up till now, we've really just seen the most basic possible manifest file. We've executed it. Now we can start building up some more complicated scenarios using this basic manifest as a starting point. So we persist the structure of this basic manifest file, but we now just add things to make it more realistic, more complicated. One of the first things we can do is to start adding more plugins into the pipeline. In the first manifest, this manifest here, all we did was initialize one plugin, just the Teeds curve model. So all we did was take CPU utilization, turn it into CPU energy. And sure, that's great. Maybe if you have some very, very limited use case, you might just want to do that on its own sometimes. But in reality, you're likely going to want to take that CPU energy, add to some other sources of energy, grab grid intensity, turn it into operational carbon, probably account for embodied carbon as well, maybe sum all those carbon values together, get some total carbon. Maybe you want to calculate some other environmental metric, like water or e-waste, or who knows. Maybe you want to aggregate your values, which will require you to snap everything to a time grid. All these things are manageable because the IF is kind of modular and composable. You just add to the plugin pipeline and feed outputs from one model as inputs to the next. And in that way, you can build up complicated calculation procedures that way. And if we don't provide a plugin that you need, well, we've also made it as easy as possible to just write your own and integrate it into your pipeline, which is something we can come back to later if we have time. The concept here is kind of similar to using a Linux pipe. If you're a Linux aficionado, you can kind of conceptualize what we're going to do here is something similar to doing something like this. Inputs, Teeds, Some maybe SIO, psi, and then output dot. Yeah, well, that is effectively what's happening when you run a pipeline. It's something very similar to that. So okay, let's get into it. Let's do it. Let's start building up a more complicated pipeline. The first thing I wanted to demonstrate was that we have some built-in generic arithmetic plugins that allow you to do just sort of arbitrary calculations over the values that exist in your output array. Okay, so let me just minimize the terminal for a second. Right now we have the option to sum or multiply parameters together, or we can multiply outputs by a coefficient. And I can just quickly demonstrate how this works. This might not be the most, this might not be the most realistic scenario. It might not be the most useful, but it demonstrates the fact that these generic models exist. And I wanted to show you because it's an important way that IF standard library allows you to generalize to your own use case. Beforehand, we had things like psi-e, and they always took the same input parameters, summed them, and they always returned energy as the sum of different energy components. But instead, now we have these generic sum, this generic sum model, and that it allows you to freely operate over any inputs. That can be very powerful later on when building up more complicated architectures. Instead of being restricted to certain inputs, you can just apply this over whatever inputs you decide. So same basic structure as before. Metadata up here, then the initialize block. This time we've got our curves, Teeth's curve again, but this time we're also going to initialize the sum model, and we're going to sum CPU energy and network energy, and we're going to output that as energy sum. Then we're going to multiply something by a coefficient, just an arbitrary thing, just for a demonstration. We're going to take energy, multiply it by 2, and add that to the output array as energy doubled. And then we're also going to use the multiply plugin to multiply CPU utilization duration. I don't know why you'd want to do that. You probably wouldn't. But for the purposes of this demonstration, it's going to be easy to see that it works, and it's going to be easy to find the output data in the output array. So let's just go with it. Excuse me. There's the tree. It's exactly the same as before. Actually, there's a couple more time steps in there than before, but it's basically the same structure. Yes, let's call it generic. Okay, so that's run, and here's our output file. There's our inputs. Here's our new outputs block, and we can see that we now have our energy doubled. This is from our coefficient model. So it's taken energy, which was 5, and turned it into energy doubled, which is 10, as you would expect. We have CPU times duration. So this was CPU utilization multiplied by duration. 50 times 1 was 50. And we have the energy sum, which was the network energy added to the CPU energy. So yep, that's all looking good. Here it is. 0.00002 plus 10 was 10.0002. So that's kind of works as expected. Okay, so those are available. They might not seem super useful in this really simplified model environment where we're demonstrating now, but you can imagine how having these is kind of a powerful unlock when you have a complicated pipeline to handle, because you can create lots of different instances of sum or multiply or coefficient that take different input parameters, different coefficients, and they just operate over your output array. So you can use it basically like a generalized calculator over your data, all inside a YAML, a manifest file. Asim, yeah, put your hand up.
Yeah, I just wanted to point out to the audience that, and the word coefficient model is kind of seems fairly basic, but a lot of what a lot of what happens in the sustainability space is taking a number and multiplying it by a coefficient. And that's kind of one of the things we want to surface here, is that whenever I'm reading any of these reports, it's like, oh, carbon emissions is X. And I'm like, well, what coefficient did you use? You just given me a number. So like I'm perfectly happy to see hackathon submissions, which is we've done a lot of analysis and we believe these are the three coefficients you should use in these three use cases. And this is the reason why. And the plugin could be very, very simple multiply plugin, which just multiplies by the coefficient. But the power, why that is important is like, if someone then generates a manifest file, it's right there and you can see it and you're not questioning, you're not scratching your head. And in future things that people might build in the future or even now, there'll be ways that you could compare a manifest file and say, well, debug a manifest file, like, well, what did you use? Like, why did you use that plugin? Oh my God, like, oh, wow. So that I think that's kind of just want to say, your coefficient is simple, but the effort to get the coefficient can be quite significant and also can be extremely valuable. Just having a plugin which everybody recognizes and uses. All that Teed's curve is a plugin which has 4 coefficients inside it. That's all that Teed's curve is, and it is used everywhere, everywhere. So yeah, coefficients are seemingly simple but extremely valuable.
Yeah, thanks. So, okay, next we will move on to a more realistic pipeline. So what I want to do is start off with some input data, which we can see down here. We have our required input, duration, and timestamp. We've also got instance types and region. We can kind of ignore those for now. Really, the two input fields that I want to draw attention to are network energy and CPU utilization. So we're going to start with those as our fundamental two pieces of data that we have. This is usage data that's available to us at the start of our pipeline. From there, we want to run the Teeds curve plugin. That will get us CPU energy, just like before. Then we're going to pass that into sum, and we're going to use sum as a replacement for what used to be. If you're familiar with the pre-refactored IF, we're going to use it as a drop-in replacement for site-E, which means it takes network energy and CPU energy as its inputs, and it returns the sum of those and calls it energy and adds that to our output array. But then we're going to run sci-O. It's actually down here. The order of it's a good opportunity to point out, actually, the order of the models in the initialize block doesn't matter. It just initializes an instance in both. It's later on when you put the plugin in each node down here that the order is important. In here, it doesn't matter. So we're going to run site-O. Site-O converts energy into operational carbon. Then we will account for embodied carbon using site-M. Then we're going to use one of our built-in plugins, TimeSync, to snap everything to a common time grid. And then finally, we will run the SCI model to generate an SCI score. So this is a more realistic pipeline of something you might actually want to do. It's a relatively complicated pipeline, but not too complicated. It's kind of manageable. Okay, so let's just look at the file and have a look at how it's constructed. We've got those models in the initialize block. Then we have our tree. We're still only using one child for this example because I want to highlight how you can make it more complicated with the pipeline before we look at how you can make it more complicated with the architecture. So for now, we'll just work on one dimension. Here we have the config for our only child one. We have the pipeline block. Now the order is important. This is where we define the actual sequence of models. We've initialized them up in the initialize block. Now we're defining the actual sequence in which they're going to execute. So we want to go Teeds curve, then sum to make sure that we have energy available, then site-M to get our embodied carbon available, then site-O, which is going to take energy and turn its carbon. Then we want to snap everything to a common time grid. Then we do our SCI calculation. Now I can just expand a little bit on the TimeSync model. This is one of our more complicated plugins. The point of the TimeSync model is that, well, if we have a look at the input data as it is in here, we can see that the time is not evenly distributed between the different timestamps. This one starts at midnight and has a duration of 1 second. The next one starts at 1 second, has a duration of 5 seconds. So this observation takes you all the way to 6 seconds past midnight. The next one takes you all the way to 13 seconds. So that's a span of 7 seconds. The next one's a 30-second observation. So time is not evenly distributed between these timestamps. They're not on a regular grid, not on regular intervals. What timesync will do when it only has one component is it will look at the global config from the initialized block, which gives a global start time, a global end time, and an interval. And it will take those observations from the input data and it will distribute them over this time grid. So it will start at midnight, it will run to 1 minute past midnight, and it will be in 5-second intervals. If we had lots of different components in the tree, meaning lots of children, it would do this for every component and snap every component to this time grid. So everything starts in the same place, ends in the same place, and has precisely the same timestamps in between, the same number of observations, the same frequency of observations, and the same actual absolute time in each observation. So we're going to do that. It's only going to operate over one component in this case, but
Sorry, Joseph.
Asim, did you want to?
Yeah, I just want to say, like, there's one extra thing just to make sure everybody understands. The reason time sync is so complicated is because it's actually changing the values as well. So if you've got energy and, it will bucket the amount of energy to the new time. It's not just going to copy it across, it'll bucket it. And it also depends on the type of parameter. So for instance, CPU utilization, it's the same utilization, you just change it over a different grid. Energy, you would have to divide it and put it on a new grid. So there's kind of each parameter, there's actually something else that we don't think we're going to have time to go into today. But each of those parameters also has like metadata about it so that we know how to aggregate it. Should we be averaging it? Should we be summing it? Should we be copying it? There's a lot of kind of power to why we've standardized the name, we've standardized the metadata, we've standardized the units, we've standardized the aggregation function. That makes everybody's lives a lot easier. And that's really the powerful thing that the time sync is doing. It's taking account of all of that for you, and getting it all on the same grid. Just really quickly, just like the other aspect of this is that it's, as you develop a manifest file, like if you're actually trying to mirror an application, you might have some components which are like servers that run continuously over a 24-hour period. You might have some components that are batch jobs that run kind of just for 1 hour every now and again. You still need to be able to represent them in the tree. You might have things that scale up and down, whatever it is. But after time sync, boom, everything's on one tabular grid, and you can then sum up and down and out and do all kinds of crazy maths on it. But James was about to show you all that now anyway.
Yeah, exactly. Thank you. Yes, so while you were talking, I just ran that manifest file. So what we're now looking at is the output file. Okay, so as before, everything's the same. It's exactly identical to the manifest file until we get to the outputs block, which has been appended. Now we can see how timesync has changed the input array. Right now we start at midnight as before, but now we're at 5 seconds, 10 seconds, 15 seconds, 20 seconds, all the way to 1 minute, which was what we defined in the global config. Which actually is an interesting point, a good opportunity to talk about the difference between global config and node level config. Global config here, which is defined in the initialize block for each plugin. This is how you configure a plugin or this is config that configures how a plugin will operate wherever it is invoked across a manifest file. This is always going to be the same for this plugin. If you imagine you have some kind of complicated architecture where the time sync model, say, is invoked tens or hundreds of times for different components, well, the global config is constant across all of those invocations. It's truly sort of global config. It's the same here for the Teets curve model. We've set the interpolation as spline. That means wherever we use Teets curve, it's going to use the spline interpolation. For time sync, everywhere it's going to snap everything to the same start, end, and interval. We just have this Boolean for padding, but we maybe don't need to go into that right now. The node level config down here, we don't actually have any here, but the node level config configures how you want the plugin to execute just in this component. So this is stuff that might vary from one component to the other, to another, but not like the interpolation method, but maybe some constant that applies across the entire time series, but not between components. Maybe I'm trying to think of an example. Maybe the lifespan of a piece of hardware, for example, that it's only relevant to that component, but it's the same everywhere in the time series. Right. Yes, one more thing to highlight here is that now you've executed this manifest file with your chosen plugin pipeline. Maybe someone comes along and says, well, okay, but I don't think much of the T-curve model. I think you should use a better plugin for calculating your CPU energy. Or maybe you're just interested in comparing between different plugins that do the same job, but with some slightly different underlying assumptions. Well, no problem. You just switch out the plugin and rerun the manifest. So we can do that now by swapping out the TEEDs for Boa Vista. We've got this Boa Vista model in the unofficial models repository, and it basically does the same thing. It's a third-party service that exposes an API that returns CPU energy. We've got a wrapper for it in our unofficial models repository, and we can just drop that in place of T-curve and re-execute this manifest file, which is otherwise identical. And we're passing slightly different values into the rest of the pipeline as a result. And you can compare how the carbon energy, whatever other metrics appear in the output data between the two versions. So we can just run that one too. Boa Vista pipeline, and update this one too. So in this example, I'm swapping out T-curve for Boa Vista. That's a model that's just swapping out two models in the unofficial models repository. You could swap it out for something you built yourself or some third-party thing. Maybe you've found some literature somewhere that's got a model that you want to test. You just integrate it in exactly the same way, only drag and drop. Just drop it in here. Well, and also here. And then execute your manifest file exactly the same. So we can just quickly check the output from that. Here it is. And you can see it's added the exact same information to the outputs. CPU utilization and CPU energy. And it's added a few other things as well, but there it is. Okay, so that was a relatively substantial pipeline. Certainly complex enough to demonstrate the concept. There might be far more complicated pipelines that people want to create, but for this demo, at least it showed you how to build something up from something very simple to something more realistic using these plugins as building blocks. And we also introduced time sync, which is one of the more useful, but also one of the more complicated plugins that we have available to us. So now we can start to take a look at some of the other ways that you can make a manifest more complicated application architectures. Okay, so far we've just used a single child component in our manifest file, which means that we're only executing our pipeline over a single array of input data. But maybe we need to account for all kinds of different structures. Maybe you want to account for your back end, your servers, your databases, your front end, some edge components, whatever. But you want to do it all in one manifest file. Well, let's take a look at how we approach that in the IF. I pre-prepared a manifest file because I thought it would take me a long time to write this live. But here's a good example. This is, yes, the same pipeline as before, exactly the same pipeline as before. But now when we look at our tree, we have children this time, instead of just having the one child, We've got child 0 with its own defaults, pipeline, and input data. We also have child 1. So there's 2 children at the top level. Then we have another child, so the 3rd child at the top level. And now this child has its own children. So this is like 3 levels in the tree now, 3 levels of nesting in the tree. There's the top level, 3 children. One of those children has its own children. And here's the first one of those children. And here's this. So there's 2 children at the 3rd level of the tree this time. So we've got 3 levels of nesting effectively. If I run this, you'll see how this is treated. Nesting 1. Okay, that's run. Let me just open the file, the output file. Here it is. Okay, so now when we go to our output file, exactly the same as before. Only now we have outputs. We're looking at outputs here. Yes, we're looking at outputs. Now we have outputs for each child in the tree. Here's the outputs for child 0. There's quite a lot of data in this output file now, so apologies, I'm scrolling through it a bit fast. But now we're on to child 1. Previous was child 0, now child 1. Here's our output data. Let's scroll down to the bottom where we have the more levels of nesting. So here's the output data for child 2, 1 and child 2, 0. So you can see each child, regardless of how deeply nested it is executed in the same way. It gets the same treatment. Its input data is passed through the pipeline that's configured at that for that component, and it gets output data just the same. Now, this is a good opportunity to cover another IF feature, which is the aggregate feature. Right? I actually ran it in that manifest file already. I just didn't mention it yet. But right at the top here, I added a block in the at the head of the manifest file called aggregation, and provided some basic config, the metrics I want to aggregate, and the type of aggregation I want to do. Now, the aggregation feature is a little complicated, but it's how you get summary metrics. And we provide 2 types of aggregation. There's the simpler type, which historically we've referred to as horizontal aggregation, which maybe we should, I don't know, we need some new terminology for that, but maybe we should call it component aggregation or something like that. But this is where for each component, you take its time series and you sum up all the values from each time step and you return a single value representing the aggregated metric. So for example, if you have a time series for carbon and you want to know what was the total carbon for the entire observation period, you just add up all the carbon from each time step and return the total. Not every metric actually gets summed. Some of them get averaged, some of them are just constants that get copied, but that's the basic concept. The second type of aggregation we've historically been referring to as vertical aggregation. Maybe it should be tree aggregation or something. I'm not sure exactly. But this is where for any component that has children, we return the aggregated time series from all of the children. So everything that branches off that parent node in the tree gets aggregated, and what you get back is a time series, not a single number this time, but a time series. It's a time series that aggregates all the children of that parent, timestamp by timestamp. So hopefully that explanation made sense. I can show you here that how it operates. Right, here's our aggregated time series. So for each timestamp in this, this is for one of the parent nodes. We get carbon and energy for each timestamp in an array. So this is for child 2. This is the aggregate of child 2, 0 and child 2, 1. Both of these have are summed. They're both summable metrics. So this is child 0 plus child 1 appended to the parent as an array. And then we also have the horizontal aggregation. So this is This is taking all of these values in the array and adding them up, basically. We get them appended to the end of the file. So,
this will become
sorry.
this is becoming a lot easier to understand once you can export it as a CSV file.
Yeah, yeah.
We're just representing the YAML file as a table. Each component is a row. Each time is a cell. And what all the aggregation is doing is kind of like summing up a row, so you know like this server for all of time how much it is. And like horizontal is like across for that 5 minute period across everything, what's your aggregated up. This is the whole thing is just a lot easier once you've got like a CSV export, because you have
Yeah,
like
it's very simple and straightforward. It's just for some reason difficult to explain.
yeah.
But anyhow, we do have some sort of prettifying to do on this at the moment. This is sort of it's functional and it works, but we need to sort of prettify the outputs. We haven't quite got to that yet, but the basic functionality is there. Similarly with the CSV export, we have a pull request open for that. I didn't want to merge it right before I did a live demo,
Okay,
so
yeah,
I
makes
decided
sense.
we would just sort of skip and come back to it next week. Okay, so I'm also very aware I've only got 5 minutes left, so I'm gonna just move on to the next piece, and if it fills the time, then so be it. But one thing I wanted to show is that so far in this workshop, we've been setting the initial conditions for executing a manifest manually. For example, providing TDP and just passing some dummy data down the pipeline for CPU util or whatever. But in reality, we want to be responsive to real applications running in some real non-hypothetical, real world situation. So we have plugins that allow for this. I'm not going to demo a real importer right now because I don't have time to set up my authorization flow and credentials and all that sort of stuff. But what I can do is show you our mock importer, which is a plugin that generates dummy data as if it was coming from some external data source, like, for example, the Monitor API for an Azure VM or something like that. This is really useful because it allows you to experiment. It allows you to experiment with IF, with the rest of the pipeline, but without necessarily connecting to a real resource. So you can kind of get your manifest file ready with the mocks, and then sort out your actual application connection later. So there's kind of a lot of config for mock observations compared to some of the others, but this is what it looks like. You use it exactly the same way as all the other plugins. You provide the mock observations key here, and then these bits of config are common to everything: the kind, the method, and the path. And then there's just a little bit more global config than there has been in the other plugins that we've talked about. We're going to use the we're going to use the mock observations plugin to create our input data. So we need to know when it starts and when it ends, and the duration for each observation. We need to create components. In this case, we're just going to create an instance type with a dummy name A1. And then the generators are the algorithms that we're going to use to generate the dummy data. So we're going to add these keys to everything. And then we're going to create random values between 1 and 99 for the CPU utilization field. And then we're going to pass that value down the same pipelines we've been using elsewhere in this demo through all of the different plugins that we've been using before. Okay, so I'm going to run it.
Well, Joe, just mentioning that, I think you mentioned mocks, but like it's not just necessarily about importers, because you might actually, it's just a really, if you're developing a plugin, it just saves you time from having to have everything downstream to kind of grab the data. If those downstream plugins might not even exist yet, and you're creating a plugin down, you might be creating a plugin for the hackathon which is exporting water, but to get water, you might need some variables. So mock observations is just a way that we've built just to quickly generate a lot of data, to quickly generate components just to help you out. Saves you from typing a lot, and you can generate very complex, like hundreds of components and thousands of time steps. So it helps you out a lot in all of that. But yeah.
Yeah, so you can see the output. It's created. It's added the expected values to each time step, and now you can pass that down through the rest of the pipeline. Um, I think we're going to have to wrap it up there because we've got like 20 seconds left for the end of the thing. The last few things I didn't get round to. In fact, there's only one thing that I didn't squeeze into the workshop, and that was about getting some granular metadata out of the Cloud Instance Metadata plugin. So maybe we can bump that and add that to next week's agenda.
Well, next week I think let's for next week let's just like dive in and focus on actually creating like I'd say one plugin, have code on the screen, and actually just
Okay,
develop like a plugin
build a
live.
plugin.
Yeah, build a
Yeah,
plugin live for everybody so they can see, the functions and just because I think most of the people would probably be building, or hopefully will be building plugins. And now with the refactor, I think it's a lot easier and a lot clearer, a lot easier to build plugins.
yeah.
So yeah, let's do that next week. That's a good thing to
Okay,
do. Yeah,
yeah, sounds good. Sounds
yeah,
good.
awesome. Thank you, Joseph. Thank you, everybody, for listening.
Welcome.
Um, Joshua's very quickly got a question. Is there documentation using an importer? There is. If you go to the IF docs, if.greensoftware.foundation, in the doc section, it's there. It might it that documentation probably hasn't been updated with the slightly refactored version, but it is not. The usage of it shouldn't change dramatically. Actually, it shouldn't change. Hang on, wait. What should have changed with the importer? I don't know.
It should,
Joseph, you answer that question.
yeah, sure. There will be minimal changes to the Azure importer after the refactor, but that model is being refactored too. So when we have the new release, everything will just naturally update itself. You can use the Azure importer exactly as before. We have a tutorial on the documentation website, which is how to use the Azure importer. So you can just follow step by step through that. And obviously we're going to make sure that that's up to date when we release the new version.
Okay, let me just get him exactly whilst uh he's here just to paste the link. If you click onto docs, where is it actually? Under reference? No. Developers.
Developers.
Oh, where's it gone? Oh, have we got rid
Did
of
we
it?
delete it? We
I think
might
we
have
might have
decided,
deleted it.
actually, I'm sorry. We might have, I think we decided just to have the README in the repository, the
Yeah.
README documentation. Send
So it's
that,
under
so send that,
plugins.
yeah. It's
If you go in,
under IF unofficial models,
yeah.
IF,
If you
yeah,
go
plugins in the
if you
documentation website.
if you go to the docs page, if you scroll to reference, then go to plugins. Inside there, you'll find a link. So Azure Importer, and and then it is there. So I'll just send you the link right now. But it's basically under the we have a section in the docs called plugins. Azure Importer is a plugin, and we link out to the plugins, and that's
Yeah,
where the documentation is. It's like the documentation of Azure Importer is with the Azure Importer repo now,
yeah,
not in the IF repo. And hopefully, ultimately, it'll be owned by Microsoft, and Microsoft will be publishing under their repository. So yeah, wonderful. Thank you all for joining, and join again next week whilst we go through an actual. Yeah, we'll start writing a plugin. You can see how that works.
thank you. Bye.
Bye.